Rethinking humanity's roots. For decades we focused on East Africa as our likely ancestral homeland. But should we be looking to the south? If you want to explore our origin story, keep an eye out for the white stinkwood trees. That, at least, is what paleoanthropologist Christine Steininger says as we push our way up a gentle incline covered in waist-tall, brown and green grasses near Maropeng, a town about 45 minutes from Johannesburg, South Africa. The land here is arid and open, except for hardy stinkwood and wild olive trees, which cling to existence in small patches. Their survival depends on putting down roots deep enough to sup on what little water collects in scattered depressions and crevices, the same spots where the fossils of our earliest ancestors have been found. Indeed, at the first strand of trees is a fissure so thick with fossils that they protrude from the breccia, a type of conglomerate rock, in cartoon-like abundance. There's enough material here for generations of scientists to excavate, says Steininger. And yet this particular trove is but one of a number that make up what is perhaps the most important network of early hominin sites anywhere on the planet. Covering an area more than twice the size of Brooklyn, the grasslands contain hundreds of complex dolomite caves, and more than a dozen early hominin dig sites with names like Sterkfontein, Swartkrans, and Kromdraat. A UNESCO World Heritage Site since 1999, its name is fitting, the Cradle of Humankind. Roughly 25 miles north of Johannesburg, the Cradle is a paradox of easy access and scientific significance but limited recognition among average citizens worldwide. You've probably heard of Ethiopia's famous fossil hominin Lucy, but what about South Africa's equally important Littlefoot? That disparity is about to change. The Cradle and other South African sites have ushered in a new golden age of discovery about our origins. Everything, from when our ancestors first commanded fire to the very shape of our family tree, is being challenged. The result? New species, new hypotheses, new controversies emerging from the deepest recesses of South Africa's cave-strewn landscape. Sterkfontein, Prometheus rises. The Silberberg Grotto at Sterkfontein Cave is locked behind a heavy gate. It's accessible via a circuitous, subterranean trek of dank tunnels and oversized ladders of the sort prospectors used during the California Gold Rush. It was here, some 20s or early 30s, that a miner blasted apart breccia to dislodge chunks of valuable calcium carbonate that could be sold to local lime works. Some of the discarded refuse studded with fossils found its way into boxes and sat mislabeled as antelope and monkey bones for the better part of a century. Poking through one of these boxes in the 1990s, paleoanthropologist Ron Clark found something peculiar: small, human-like ankle bones. Surprised by the discovery, he sent two of his assistants on a near-impossible quest: go into the cave with torches, Clark recalls telling them, and see if you can find anywhere. On the second day, they found the spot. But excavating the fossils from the concrete-like breccia was not a quick process. Only now, nearly 2 decades since digging began, is Littlefoot named for those initial small foot bones being fully assembled. The result is stunning. Among Australopiths, the hominins immediately ancestral to our own genus Homo, Littlefoot is by far the most complete specimen ever found. Photos of its fossilized skeleton look more like a modern forensic scene than something that's been locked underground for millions of years. Much of what we know of human evolution comes from fragments and incomplete fossils, opening the door to misinterpretation. By contrast, the completeness of Littlefoot's skeleton means we're more likely to gain a fuller understanding of its species, as well as where it fits in our family tree. Clark has described its mix of ancient and modern body parts: hands with short palms and fingers like our own, a big toe that could grasp like an ape's, widely spaced eye sockets and large, bulbous molars. Adds Clark, the legs are definitely longer than the arms, not the other way around. Littlefoot was made for walking upright, and it didn't drag its knuckles. Perhaps the most striking thing about Littlefoot came to light only last year: it's 3.67 million years old. Until Littlefoot was found, The earliest hominin species known in South Africa was Australopithecus africanus, which is generally believed to have lived between 2 million and 3 million years ago. Many anthropologists have argued that A. africanus couldn't be our direct ancestor largely because of timing. The earliest known members of the genus Homo, though their classification remains controversial and their fossils fragmentary, turn up in East Africa soon after A. africanus appears in South Africa. This suggested that A. africanus was a parallel evolutionary line to our own, and that some other species gave rise to the line that eventually became human. For decades, before the diversity of early hominids in Africa became apparent, many researchers believed that humanity's most likely direct ancestor was East Africa's Australopithecus afarensis, best known through the famous 3.2 million-year-old Lucy. Clark argues that Littlefoot, which he classifies as Australopithecus prometheus, represents a more primitive, separate species from A. africanus. And Littlefoot's recently established age, making it contemporaneous with A. afarensis, raises questions about whether Lucy really was ancestral to us or merely a distant cousin. There's an even more complicated possibility. It may be that these fossils that we're finding now, these hominids, had descendants that became extinct, says Clark, and that we haven't yet found the direct lineage of our ancestry. Malepa, everything up for question. Less than 10 miles from Littlefoot's Sterkfontein, a site called Malepa sits on a hillside of scraggly acacia trees that are stalked by a resident leopard. It was here in 2008 that Matthew Berger, the young son of American paleoanthropologist Lee Berger, found a fossilized clavicle sticking out of a rock. The discovery would shake up the world of paleoanthropology. As the elder Berger and his team excavated, they were shocked to uncover a fairly complete Australopith skeleton. Then another. Then parts from 4 more. Finding a new dig site with such a dense cache of fossils was a surprise. Up until that point, you have to remember, on the continent of Africa, no one had ever found 2 skeletons, and suddenly we were finding more, says Berger. In fact, prior to Malepa, so few new sites had been found in Africa that in 2000, at least one leading paleoanthropologist suggested that the field might as well stop looking. Another surprise, the skeletons with a mosaic of modern and ancient anatomy represented a new species. Dated to around 2 million years, the individuals at Malepa were classified as Australopithecus sediba. The holotype specimen, used to describe the species, was a juvenile male given the name Carabao. Once reconstructed, it was clear that Carabao had arms suitable for climbing and a brain not much larger than a chimpanzee's. But his teeth and hips were much like our own, his hands capable of tool making. He also had a unique, hyperpronating way of walking unlike anything seen before. Carabao's anatomy was so peculiar that, had the skeleton not been found all at once, paleoanthropologists might have thought its various parts came from different species altogether. The foot had more primitive features than other hominids we think are primitive to this. The heel is chimpanzee-like, says Berger. That's a problem. Because if you look at afarensis, Lucy's species, that's got a heel that's like a modern human's. You have to start driving uncomfortable questions, Berger says, like maybe it's coming from something we haven't seen. Maybe there are other lineages out there. Like Clark, Berger believes the labels on the tree of human evolution could be wrong because we haven't found all the species, or branches, that make up the tree. We may have attached evolutionary branches in the wrong places, building false relationships between species that didn't give rise to one another. Even more tantalizing were the results of a recent meta-analysis using 13 datasets, composed of 20 previously described hominin species and their fossils, and covering all 7 million years of human evolution. The study found Carabao most likely to be ancestral to the genus Homo but not a descendant of A. africanus. The research, focusing on cranial and dental features, was the first of its kind to compare competing hypotheses on the relationships between various hominin species using a complex method known as Bayesian analysis. Despite the results, however, the issue of timing complicates our understanding. Carabao was estimated to be living shortly before fossils of Homo show up in South Africa. There are Homo fossils in East Africa that precede it by hundreds of thousands of years. Aesodiba remains an enigma. Carabao could be the last Australopith before Homo, or a species that evolved after the Homo lineage split from the Australopiths, similar to the relationship between us and our Neanderthal cousins. It could even be a late version of A. africanus. Most disruptive of all is the suggestion that not all the species grouped within our own genus are necessarily from a single lineage, or that, perhaps, some of the species considered Homo, such as Homo habilis, are really Australopiths. Wonderwork in Cothu, behavioral clues. Just over 300 miles southwest of the Cradle, in South Africa's northern Cape Province, is the country's middle of nowhere, on the edge of the Kalahari Desert. It's a land covered in giant iron ore mine dumps that resemble mountains. The area also a remarkable collection of early hominin artifact sites, which are in danger of being damaged or destroyed by the extraction industry's boom and attendant economic activity. The density of stone artifacts in the region is staggering. At a site called Cothu Townlands, beautiful, teardrop-shaped Acheulean-style hand axes, possibly dating to around 1 million years old, litter the ground. 3 miles down the road, behind the parking lot of a rental car company and within frightening of heavy mining trucks, is the equally important Cothu Pan dig site. Here, researchers have found 4 smith stone blades longer and narrower and more advanced than Acheulean axes that are around 400,000 to 500,000 years old, nearly twice the age of those found anywhere else on the planet. This raises questions about which of our ancestors created such advanced tools so early. Did the human way of life arrive suddenly with modern Homo sapiens, or did we gradually acquire the stuff of modern behavior via our ancestors? About an hour's drive away, at Wonderwork Cave, the University of Toronto's Michael Chazon and colleagues are overseeing fresh excavations that may help answer these questions. The digs may also unearth evidence to support 2 theories about what ultimately made us human. The late archaeologist Glenn Isaac suggested it was a social structure built around communal life in protected base camps, while primatologist Richard Wrangham believes it was the use of fire by Homo erectus, as early as 1.8 million years ago. So far, evidence of fire at Wonderwork goes back 1.1 million years, strengthening Wrangham's claim, but Chazon is confident current excavations will push that date back further. What he is less certain of is whether Homo erectus was living in camps, or that the oldest use of fire at Wonderwork will resemble the closely tended fires used by modern hunter-gatherer groups. Wrangham's hypothesis, says Chazon, is that the use of fire was like an on-off switch. Once toggled, humans from H. erectus to our own species developed culture and society around the fire's glow. Once our ancestors began using it, fire drove evolution. The shift to cooked meals propelled changes to tooth, gut, and brain size. It's still unknown whether this hypothesis will be borne out by Chazon's work and whether early hominin fossils will be found at Wonderwork or Cothu to reveal just who built the tools and manned the fires. As the dig continues, one thing is certain. In terms of what fire means for human evolution, it's absolutely critical, says Chazon. And this is the place to look for it. Rising star, tip of a mystery. Back in the Cradle, little more than a mile from Sterkfontein, a mystery has emerged from the depths that could explode our understanding of our family tree, as well as what it means to be human. In September 2015, Berger and his team published the massive trove of fossils, 1,550 fragments from at least 15 individual hominins from the Dinaledi chamber of the Rising Star cave system. Not without controversy, Berger said these fossils represented yet another new species, this time from our own genus, Homo naledi, or star man. Rising Star's significance is tremendous. The site contains, by far, the most hominin fossils found in a single excavation, including the only fully articulated early Homo hand. Like Aesodiba, H-D has a disparate mosaic of ancient and modern anatomical features. But what caught the world's attention was where the fossils were found, deep within the cave, beyond nearly impassable shafts, alone, without other material, such as the bones of prey animals. The best explanation, the authors wrote, was that H-D was put underground by its kin in a form of deliberate body disposal. Although H-D's cranium is shaped like that of H. erectus, its brain size is that of an earlier Australopith, and tiny for its 5-foot-tall body. Its small brain challenges an assumption that large brains are required for complex behavior, such as negotiating the cramped depths of a cave, in total darkness, apparently to dispose of its dead. It's a non-human species of animal, says Berger, that's doing something that we thought perhaps defined us, and by us, I mean us sitting in this room. Whether or not the remains were really brought into the cave intentionally, it will be difficult to determine how old they are. The researchers hope to get a rough age range for the fossils by dating Stone's calcite structures formed slowly by dripping water in adjacent rock layers. And though paleoanthropologists see the rising star discovery as a major breakthrough, some question whether there's enough evidence to prove that the hominins found in the cave are a new species. These same critics argue that without an age for the fossils, rising stars' ability to shed light on the course of human evolution is limited. Such debates are the stuff of science, requiring time and rigorous work to resolve. But what is certain is that as we attempt to unravel the deepest of human mysteries, our origin story South Africa will be a growing part of the discussion. The East Side Story, as Berger refers to paleoanthropologists' decades-long focus on East Africa as humanity's homeland, is moving south.